Okay, we have an oil tanker with its tank full of oil and it float. So the total weight, which includes the weight of the oil, must be exactly balanced by the upthrust it received from the seawater, because there are only two forces acting on the oil tanker, weight and upthrust. So if it floats, these two forces must be equal but opposite. So now we empty this tank, which means the total weight reduces. So the oil tanker doesn't have to displace so much seawater in order to stay afloat. So in fact, the oil tanker will float higher. So there's a reduction in the upthrust. So we can write this equation here. The reduction in the total weight, which is of course the weight of the oil in the full tank, must be equals to the decrease in the upthrust. The decrease in upthrust, of course, I'm going to write it as rho Vg. So this is the rho, the density of the seawater. The V here is actually the reduction in the volume of seawater displaced. So the reduction in the volume can be calculated by the cross-sectional area of the oil tanker multiplied by the amount of the height that it has risen up, because that represents the change in the volume of seawater displaced. So rho Vg, so instead of V is just the delta V. Alright? And then you get the answer. Okay, ta-ta!